In the year 1929, a group of scientists created a theory. According to our greatest theoretical physicist the world saw, Richard Feynman, it is the jewel of the physics. It is a theory which gives an explanation for the interaction between light and matter. It is known as quantum electrodynamics, for short QED. But at that time, it was greatly flawed because of the lack of equipment and lack of precision of that equipment. So, it was actually taken upon seriously when Feynman himself did some series of experiments and proved a QED theory of Paul Dirac, which was proposed years ago. Again, an example how the pure physics is not important in the eyes of public. That too, this happened in 1950s. Now it has gotten considerably worse than 1950. Hi, I am Vivek and this is Exposed. Today, with yet another mystery of physics, which is not solved because of the hypocrisy of mankind. It is the simple principle of partial reflection, what we witness every day on any glass surface, on cars, windows, spectacles, or any glass surface for that matter. Previously mentioned QED has a very good take on this partial reflection. What they have done is they haven't actually found the answer why it is happening, but have collected data over different types of surfaces and have come to a conclusion. Basically, they have not found the answer for the question why, but have answered how. Photomultiplier is the equipment used to conduct most of the experiments of QED. When a photon hits the metal plate A at the bottom, it causes an electron to break loose from one of the atoms. The free electron is strongly attracted to plate B, which has a positive charge on it, and hits it with enough force to break loose 3 or 4 electrons. Each of the electrons knocked out of plate B is attracted to plate C, which is also charged, and their collision with plate C knocks loose even more electrons. This process is repeated 10 or 12 times until billions of electrons, enough to make a sizable electric current, hits the last plate L. This current can be amplified by a regular amplifier and sent through a speaker to make audible clicks. Each time a photon of given color hits a photomultiplier, a click of uniform loudness is heard. Now coming back to partial reflection, consider a light source which emits red light down toward a block of glass. A photomultiplier is placed at A above the glass to catch any photons that are reflected by the front surface. To measure how many photons get past the front surface, another photomultiplier is placed at B inside the glass. Never mind the obvious difficulties of putting a photomultiplier inside a block of glass. What are the results of this experiment? For every 100 photons that go straight down toward the glass at 90 degrees, an average of 4 arrive at A and 96 arrive at B. So partial reflection in this case means that 4% of the photons are reflected by the front surface while the other 96% are transmitted. Already we are in a great difficulty. How can light be partially reflected? Each photon ends up at A or B. How does the photon make up its mind? Whether it should be at A or B. First, when Newton encountered this, he thought it may be due to the minute ridges on the surface of the glass. But he wrote in his book that is not the case because he can polish the glass and it would cover up any minute ridge there is. After many years of pondering how photons make up its mind, whether to hit the surface or go through it to the other side, scientists who were working on this gave up answering the question why and started collecting the data. They now have data from many different versions of the same experiment. Many experiments with varying size of the glass slab. For collecting this data, they slightly modify the experiment by placing the photomultiplier outside the slab. They did this because this is the experiment which makes more sense than the previous one. This opens the possibility of light reflecting from top surface and also the bottom surface of the glass. After collecting the data, what they have obtained till date is that there is a wavelength pattern of the number of photons reflecting and not. The number of photons reflecting starts from 4% and as the thickness of the slab increases, it reaches 0%. At certain point, light doesn't reflect at all. This wave has been tracked until the thickness of the glass is up to a couple of meters, starting from microns. But all they have found is just a wave and don't know why it's a wave and why not a straight line. The only positive takeaway from this experiment is to manufacture glass slabs which doesn't reflect light at all, and 0% improvement in pure physics. All I am saying is the course of scientific study is to first formulate a theory and then conduct subsequent experiments, and not just smashing things around with no reason and creating some more things. Think about it. Thank you for watching. Peace out.